maximum a posteriori probability. So mostly this is with respect to the receiver side. இது நம்ம டிஸ்கஸ் பண்ணோம்னா நம்மளுக்கு பைனரி சிமெட்ரிக் சேனல் ஃபார்மேட் இதெல்லாம் தெரியணும். ஆல்ரெடி டிஸ்கஸ் பண்ணியிருக்கோம் பைனரி சிமெட்ரிக் சேனல். Say for example, I am having some symbol A0 and then A1. Say this is corresponds to 0. This is corresponding to 1. Again, I know what is the probability of occurrence of 0 and then probability of occurrence of 1. Then we know that generally the error may be there. What is the probability that 0 will be treated as 1? Again, similarly, one symbol may be treated as 0. One symbol may be treated as 0. So in general, I am putting B. I do not know what is B. I have to decide. Either it may be 0 or it may be 1. Okay, B can be 0 or it can be 1. It all really depends on the probabilities. At what rate the data are generating, and then what is the probability of error in the binary symmetric channel. And then to discuss all this, we need to know some of the basic formula with respect to the Bayes theorem. Say, I have received B. Suppose I know probability of B given, that means at the output side, then what is the probability A0 has been transmitted? What is the probability A0? That means 0 has been transmitted. Okay, that we can calculate using Bayes theorem like this. Probability of B given A0, probability of A0 divided by probability of B given A0, then probability of A0, then probability of B given A1, and then probability of A1. Then similarly, probability of A1 given B is equal to probability of B given A1, probability of A1, then probability of B given A0. Okay, the denominator is same, numerator only will be differing. Probability of A0, then probability of B given A1, probability of A1. In general, probability of A0 given B or probability of A1 given B. Okay, probability of A1 given B is equal to 1. Okay, is equal to 1. Probability of A0 given B plus probability of A1 given B is equal to 1. Now, what is this probability? Probability of A0 given B and then probability of A1 given B. That means I have received something. Okay, given that, what is the probability that A0 or symbol 0 is transmitted? Here, I have received something. What is the probability that A1 has been transmitted? Okay, so this probability we'll call it as a posteriori probability. Probability of A0 given B or probability of A1 given B. Okay, so now I have to decide. I have received something B, whether it is A0 or A1. Okay, depending on the probability values, I have to decide. Okay, what is the actual value at the output side? What is the actual value at the output side? So these two probabilities is called a posteriori probability. And then probability of occurrence of symbol 0 or the probability of occurrence of symbol 1 is called prior probabilities. And then the reverse of these, say probability of B given A0 or probability of B given A1. Okay, that means in the reverse. So I have transmitted A0. I know A0 has been transmitted. Then what is received? Similarly, I know A1 has been transmitted. Then what is received? This probability is called likelihood probabilities. This probability is called likelihoods probability. Suppose at the receiver side, if you are making decision based on this probability, whichever is higher, say at the receiver side you are making decision based on this scheme, that particular kind of receiver is called maximum likelihood receiver. Maximum likelihood receiver. Maximum likelihood receiver. Suppose at the receiver side, if you are doing decision based on the likelihood. That receiver is called maximum likelihood receiver. Again, here the major problem with this estimation, okay, comparison or estimation with this technique, maximum likelihood receiver technique, is it will not minimize the probability of error. So main problem with this ML technique disadvantage, the disadvantage of maximum likelihood deduction is it will not minimize the probability of error. It does not minimize probability of error. But once if we really take the numbers, then we can understand this, whether we are getting minimized probability or not finally. But anyway, only expression we will be doing now. Okay, so in case of in case of a posteriori probability, how we will be taking the decision? Say, suppose we will call again, we know that probability of B given A naught, comma, probability of B given A1 is the A posteriori probability. If probability of B given A naught is greater than probability of B given A1, then I will make decision in favor of symbol 0. Then I will make decision in favor of symbol 0. So that means the likelihood of, yes, we made a mistake. This is with respect to likelihood. Now we want to discuss with respect to the A posteriori probability. So A posteriori probability. Suppose probability of A1 given B and then probability of A naught given B is the A posteriori probability. A posteriori probability. Suppose if we are making decision based on this probability, say one may be greater than others, probability of A1 given B may be greater than probability of A naught given B. So we have received something, then what is the probability that A1 has been transmitted or A naught has been transmitted? Once if you are doing decision based on this, then we will get the minimized probability of error. So this kind of technique will minimize the probability of error at the receiver. So this technique minimize the probability of error at receiver, probability of error at receiver. So that is the main thing. So mostly out of this ML and MAP technique, so we will get the minimum probability of error using the A posteriori technique. That is the final conclusion.